So let's first quickly review what we have discussed in the last class. So basically the idea is if a firm is using debt, then the firm will incur some interest payment. But the nice thing about interest payment is it is considered as an expense. So it will not be taxed, right? So this basically means the interest payments to debt holders will be shielded away from corporate tax. And this shield, this interest tax shield, will increase the total cash flow available to debt holders and shareholders. Larger cash flow will increase the firm's value. So the logic is because of the interest tax shield, a firm could become more valuable, right? So, and a important question is, how do you exactly calculate the value of interest tax shield? A related question, obviously, is how do you calculate a firm's value when this firm is using debt, right? So that is our task today. That is value interest tax shield. So first, let's talk about MM proposition with taxes. So remember, we discussed MM proposition 1 without taxes. It basically says, V equals E plus D. That is, a firm's value equals the market value of equity plus debt. And this, and more importantly, this V is fixed no matter what is your capital structure, right? So the firm value stays the same no matter how much debt you use. That is the basic result of MM proposition 1. Now, MM proposition 1 with tax will be different. And you can see that basically it says the value of the firm with debt is larger compared with the value of the firm without debt. That is, leverage can increase a firm's value. Right? So you can see that mathematically this implies that a firm's value with leverage equals the firm's unlevered value plus the value increase because of interest tax shield. So for simplicity, we can call this guy as levered firm value. Right? So levered firm value. And this is basically unlevered firm value. Right? So you can see that if you want to understand how debt affects a firm's value, it's very important for you to understand how to calculate the present value of interest tax shield. And we will discuss 3 different cases. These cases are actually very basic and very simple. The first case is the constant interest payment. The second case is the constant permanent debt. And the third case is constant debt equity ratio. Both the first and the second case, they're very simple. And the third case is slightly more complicated compared with case 1 and 2, but still it's very simple. Now let's discuss the first case. That is, you have constant interest payment. And we will discuss this using an example. So let's say this firm DSB plans to pay $100 million in interest payment each year for the next 10 years, and then repay the principal of $2 billion in year 10. These payments are risk-free, and its marginal tax rate would remain 35%. If the risk-free interest rate is 5%, by how much does the interest tax shield increase the value of DSB? So by proposition 1, VL equals VU plus PV interest tax shield. So here our task is we want to find out what is the present value of the interest tax shield, right? And we know how to calculate interest tax shield per year, right? We know that interest tax shield equals corporate tax rate times interest payment, right? And we know that interest payment here is given by 100. And corporate tax rate is 35%. So it's 35. Now, if you draw this out, right, it basically means for the next 10 years, every year, the firm will get this 35 million interest tax shield. That's bad. And our task here is we want to value what is the present value of these 10 interest tax shields. So you can see that this is equivalent to value a 10-year annuity, right? So this is equivalent to value a 10-year annuity. And you guys should have learned about annuity in Corporate Finance 1. So this is a 10-year annuity, pays you 35 million per year, right? So according to the valuation formula, we could find out the present value of the interest tax shield is 1 divided by, you know what, I cannot remember exactly. I think it's interest rate and 1 minus 1 plus interest rate and 10-year and times per year payment. Let's see if it's correct. Oh, I'm actually correct, right? So this is how you calculate the present value. So this is $270 million. So you can see that this is a very simple calculation, right? You just consider the 10-year cash flows of this interest tax shields as a 10-year annuity. Then you could use the annuity valuation formula to find out the present value of these 10 interest tax shields, right? Okay, now let's talk about the second case. It's actually somewhat a weird case because this case is about the interest tax shields with permanent debt. So the key here is the firm is taking on a permanent debt. So we assume the firm keeps the debt level D forever, right? So this basically means the firm is maintaining the same level of debt, right, forever. Now, what is the present value of the interest tax shield in this case? You can see that it's actually very easy to find out how do you calculate this. So basically, present value of interest tax shield equals present value of corporate tax rate times interest payments, right? Because we know that interest tax shield equals corporate tax rate times interest payments. However, if we assume corporate tax rate will not change, if we assume this, we can basically move this corporate tax rate to the front. And now we will get this formula. However, what is the present value of the future interest payments? It's just D, right? it's just D here. So the present value of the future interest payments is the value of the debt. Because by the Corporate Finance 1 valuation technique, we know that when you're valuing a bond, right, its value is basically the discounted cash flow of all future interest payments, right? So basically the present value of interest tax shield equals corporate tax rate times times the level of debt. One important note here is you can use this formula to value both riskless debt and risky debt. A special case is when debt is riskless. Of course, we know that if this permanent debt is riskless, the valuation formula is still the same, right? Corporate tax rate times the level of debt. And you can see that why this is the case when the debt is riskless, because the interest tax shield equals tau C times interest payment divided by RF, right? Because this is like a perpetuity. Remember that this firm is holding this debt forever. So it has to pay this interest payment every year, right? So this is like a perpetuity. When you're valuing a perpetuity, its present value is just every year's cash flow divided by the discount rate, right? So for each year, the interest tax shield is given by corporate tax rate times this interest payment, right? And we know that interest payment is given by interest rate times the amount of debt. And you can see that the interest rate would just cancel out. So this gives you corporate tax rate times D, right? Okay, now let's discuss a third case. That is value interest tax shield with the target debt equity ratio. So here the basic assumption is this firm is having a fixed target debt equity ratio. That is, it maintains the ratio of E versus D, right? So these ratios are the same. And then through calculating WACC, remember WACC refers to the weighted average cost of capital. Through calculating WACC, you can see why debt could increase a firm's value. So the formula of WACC, of course, is this, right? And you can actually decompose this second term, right? If you decompose the second term, it becomes the ratio times our D minus the leverage ratio times our D minus tau C. That is, you will get this longer formula. And you can see that this part is just pre-tax WACC. And what is this? Well, notice that you have a minus sign here. This basically tells you that if you increase D, if you have more debt, this reduction here will be larger, right? Basically, WACC equals pre-tax WACC minus this reduction. And this reduction increases in the amount of debt. So as you take more debt, you will get higher reduction in the cost of capital. So this will benefit your firm. And we could also see this result from this nice picture. So what you can see here is, first you can see that you have this pre-tax WACC, which is a horizontal line, right? So we assume pre-tax WACC measures the risk of this firm's asset or the risk of this firm's business operations. So if we assume the firm's business operations are not affected by the firm's capital structure choice, then we can see that the pre-tax WACC should stay constant as you increase the debt level. But what you can see here is this debt cost of what you can see here is this debt cost of capital, right? This debt cost of capital, it will be lower because of using debt. Because without debt, the debt cost of capital is just RD. But with debt, the debt cost of capital becomes RD times 1 minus corporate tax rate, right? So that's why you get this guy here. That is the after-tax cost is actually lower, right? So that's why the debt cost of capital RD will shift down, become RD times 1 minus corporate tax rate. So this is the saving on your cost of capital because of debt, right? And you can see that the WACC with debt becomes lower and lower as you increase the amount of debt, right? So this basically says the firm's capital becomes cheaper as you increase debt. Now, how do we value a firm's interest tax shield if the firm is using a target debt equity ratio, right? How do we do this? Well, so let's say the firm is using a target debt equity ratio. And let's say we use VL to denote the levered firm value and VU to denote the unlevered firm's value. Obviously, by VL equals VU plus present value of the interest tax shield, we know that present value of interest tax shield equals VL minus VU, right? So if we can find out VL and VU, we could use we could use their difference as the present value of the interest tax shield. But how can you find out VL? Well, if the firm is using a target debt equity ratio, then VL, that is the levered firm value, can be computed by discounting its free cash flow using WACC. For VU, it can be calculated by discounting its free cash flow using pre-tax WACC. So that's the difference here. The cost of capital is different for VL and VU. For VL, you use WACC. For VU, you would use pre-tax WACC. Now let's see this example. And this example will give you a clear idea how to exactly calculate the present value when this firm is using a target debt equity ratio. So let's suppose this West Fraser Timber Company is expected to have free cash flow in the coming year of $4.25 million. And its free cash flow is expected to grow at a rate of 4%. Let's say the firm has the equity cost of capital of 10% and a debt cost of capital of 6%. And it pays a corporate tax rate of 35%. Let's say if the firm maintains a debt equity ratio of 0.5, what is the value of its interest tax shield? So we have said to solve this, we have to discount cash flows using WACC and pre-tax WACC. So let's start with pre-tax WACC. Clearly we have RE, right? So RE is 10%, RD is 6%. So we want to find out E divided by D plus C. How do you find out this? Well, look at this problem. It says debt equity ratio is 0.5 or 1 over 2. So you can consider D as 1 and E as 2. So this implies, so this tells us, E divided by D plus E equals 2 over 3, right? And D divided by D plus E equals 1 over 3. Right? So now we could use these ratios. So this is 2 over 3. RE would be 10%, 1 over 3, and 6%. So this gives us a value of, let me see, 8.67%, right? Okay, great. Now let's find out WACC. Obviously now you have all the data you have to calculate WACC, right? So this would be 2 over 3, 10%, 1 over 3, 6%, 1 minus the corporate tax rate, 35%. This gives us 7.97%. Now let's value the firm's cash flows. So the levered value. So we will use the constant growth model, right? Because we know in the first year you will have 4.25, and you would grow your free cash flow at a rate of 4%. So minus 4%. Here we are calculating WACC. So, here we are calculating levered value. So we would want to use WACC here, right? So what is WACC? Well, it's 8.67%, all right? What about VU? Again, same cash flow, same constant growth rate, but the difference is you will use a different cost of capital. You would use pre-tax WACC, right? So, clearly here I should use WACC. So it should be 7.97%. So to calculate unlevered value, you would use pre-tax WACC, which is 8.67%. So what numbers do we have here? VU would be $91 million. VL would be 107. So the value of the interest tax shield is 1 over 7 minus 91, which is, I don't know, 16? Yeah, $60 million. Okay. Now let's look at a very interesting example. Again, it's this recapitalization, right? So it's again about the leverage recap. Remember that We have discussed the leverage recap in the last chapter when we were discussing MM theorem without tax. And we know that in that case, we learned leverage recap does not create value, and the firm's stock price would stay the same, right, after the leverage recap. But now we are thinking about a more realistic case. That is, if the firm is using debt with corporate taxes, that will create interest tax shield. So you can imagine that if a firm is doing this leverage recap, then because of this larger interest tax then because of the larger interest tax shield from this additional debt, the firm's value should increase, right? And you could also guess the firm's stock price will increase, right? Okay, now let's look at this example. Oh, remember what is the meaning of leverage recap, right? So basically the firm will issue debt and get some cash from the debt issuance. And then the firm will use the cash from the debt to repurchase some shares from other shareholders. So basically the number of shares will become smaller after the leverage recap, and the firm's debt level will increase, right? Okay, so there's a firm, Midco Industries. It has 20 million shares outstanding at $15 per share, and it has no debt. So again, this firm starts as an all-equity firm. Midco plans borrow $100 million using permanent debt to repurchase shares. So the keyword here is permanent debt, right? As long as you see this, you would know that how to value this interest tax shield, right? It's basically the level of debt times the corporate tax rate. And corporate tax rate is 35%. Now, what's the question? The question is, can the tax savings from this transaction boost stock price and benefit shareholders? So how do you solve this? Well, the starting point is you have to understand if the firm is using debt, then the firm's total value should increase, right? So let's see how to calculate the firm's value, right? You can see here, in the beginning, the firm has 20 million shares. Share price is 15. So the firm's unlevered value is 20 times 50. So it's $300 million. Now what is VL? Well, we know VL equals VU plus the value of interest tax shield, which is basically 300 plus 35% times $100 million, right? So the corporate tax rate times the level of debt, the amount of debt the firm is using. So this would be 335. So you can see that because of using debt, the firm's value has increased for $35 million, right? And now let's see how shareholders could benefit. So what you can see here is through this leverage recap, if you look at this example here, the firm will use this $100 million to repurchase shares. So what will happen is, if you look at this firm's market value balance sheet, you can see that after repurchase, the firm's asset will be worth $335 million. And this firm will have $100 million of debt. And the firm's equity will become 235. So you can see that after the repurchase, there will be a total worth of $235 million of stock in the market. Okay. Now, our question is, how would the stock price change? Right? So let's assume we will have the same result as our last chapter. That is, let's assume when the firm Midco is repurchasing shares in the market, the share price stays the same. So let's assume Midco could repurchase shares at $15 per share. Now, let's see what will happen if we assume the firm can repurchase at 15. So, repurchase at $15. The firm will spend $100 million. So if the share price is staying at $15, now the firm can repurchase 100 divided by 15, which is 6.67 million shares. Right? So what is the leftover? So there will be 20 million shares minus 6.67, which is 13.33 million shares left in the market, right? And we have learned the total equity value after the leverage recap is 235. So we can find stock price after repurchase. Is given by 235 divided by 13.33. Let me see what's the answer here. So this gives us 17.2. So 17.625. Now, is this answer correct? Well, if you think about this, you can see that this answer is incorrect. Why? It's actually very weird. It's not logical because look at our assumption here. We assume the firm can make the purchase for $15 per share. And after the repurchase, the share price will increase to $17.6. This is illogic because if you're the shareholder, you will understand after the share repurchase, the share price will increase from 15 to 7.625. This implies that you will never want to sell your shares to Midco at this 15 price, right? Which implies it's not possible to Midco to make the purchase at $15. So the assumption that purchase at $15 is not correct. So what is the correct approach? What is the correct approach to solve the firm's stock price? Well, okay. Let's see what's the correct approach. So the correct approach is like this. These investors, they understand the price will increase because the firm's value will increase from the interest tax shield. So as long as the firm tells the investors they will want to, let me rephrase this. So as long as the firm tells investors it wants to do this leverage recap, then investors will demand this premium. That is, they understand this repurchase will increase the firm's value. So they will demand a higher stock price, right? So how do you calculate this higher stock price? Well, it's actually very easy. After the firm announces it will want to do a leverage recap, then all shareholders will understand the firm's value it will increase from $300 million to $335 million. And the firm has not made its repurchase yet. So it still has 20 million shares outstanding. Now the share price would be 335 divided by the total number of shares, which is $16.75. So let's see the correct process here. The correct process is you understand the firm's value will increase from $300 million to $335. And you know there are 200 million shares. So this solves the correct answer. Very simple, right? The key here is you have to understand all original shareholders will enjoy this increase in firm's value, right? So basically you can see that the shareholders gain would be 16.75 minus the original share price 1.75. Obviously, if you use 1.75, which is every shareholder's gain, times the total number of shares, this gives you 35, which is exactly the present value of interest tax shield. So you can see that this again tells you that all the original shareholders, right, they will capture the full benefit of the interest tax shield from an increase in leverage. Obviously, you can see that this is a simple, a very simple calculation, right? The only difficulty here is you have to understand this conceptually, right? So basically, you have to understand every shareholders, no matter you want to sell your share to Midco or not, you will enjoy this benefit. And this benefit is calculated by the firm's levered value divided by the total original number of shares, right? I am emphasizing this because even now it looks very simple, but still in the past, people would make mistakes, right? And you also don't want to mix the leverage recap with tax with last chapter's leverage recap, right? So remember that leverage recap without tax, in that case, stock price does not change. Here, stock price changes. So don't mix these two different cases in your exam. Okay, now let's see this table, which gives you the clear picture on how this process works. So we basically have three different periods. Right? So you have this initial period. And in period 1, the firm says, hey, I want to do this leverage recap. And for the third period, the firm will actually issue some debt and the firm will raise cash. And in the final step, the firm will use the cash raised from the debt to do this stock repurchase. So now let's see how the asset liability will change and how the share price and shares outstanding will change. So on the initial date, the firm has no cash and its total asset is $300 million, which is solved by 20 million shares times $15 per share. And on this initial date, this firm is a all equity firm, so there is no debt. Next, on step 1, the firm announces there will be leveraged recap. So in this case, you can see that the firm's interest tax shield will increase by $75 million, which is given by the amount of tax times corporate tax rate. Right? So it's basically 100 times 35%. And because of this increase in the interest tax shield, the firm's total asset will increase from 300 to 335. And accordingly, right, the firm is still having no debt because at this stage, the firm is just telling its shareholders it will do a leverage recap. Right? So the debt has not been issued yet. In this case, debt is still zero. And the market value of the market value of equity has to be the same as the market value of asset. So in this case, you can see that the equity will become 335. The shares outstanding is still the same number, 20 million shares. So this gives us the price per share. And next, on the step 2, the firm will actually issue the debt. So what you will see here is the firm's debt will increase. Right? It will have this $100 million debt. And from the debt, the firm will get 100 million cash. So both the asset and the liability will increase by $100 million. And of course, total asset will become $435 million. Next, the final step, the firm will actually do this share repurchase. So what will happen here is the firm will spend this $100 million to repurchase shares. At what price? Well, at this price. So the number of shares will be repurchased by the firm is given by 100 divided by the share price, which is given by 6. Oh, I forget what's the. Okay, let me check. How many shares? I actually don't have a number for this. Okay, let me use the calculator. Okay, so it's 597. It's 597. So you can see that there will be 14.03 million shares left in the market. And the firm spends $100 million of cash to repurchase shares. So the cash will decrease to zero. And accordingly, the equity will decrease from 335 to 235. And of course, now you could find out the share price, right? This number is essentially given by 235 divided by the number of shares outstanding, right? So so 235 divided by 14.03 equals this share price. Okay, that's for today's class because we don't have time to finish this example. We will discuss this example in the next class.